Hey, this is Unit 7.2, Transforming the Log. I just realized that last screen on 7.1 should have been with this one, but it's okay. You've got it in your notes ahead of time. If you were a little bit lost, you might understand it now. Here is the equation for transforming the log. Go ahead and get that in your notes. Pause. Get that in your notes. Now you already know what A does, stretches and shrinks. The negative reflects, the H goes left and right, the K goes up and down. It's the same on all functions. Even when you get into trig, you'll see the same thing. Okay, so changing the H and K values. What I always look at is what I call the vertex on these, which is 0. I'm sorry, I should say 1, 0. I think in the other film I said 0, 1 as well. So it's 1, 0. I am going to go 3 to the, hopefully you said right, and up 2. So I take this point and I go 1, 2, 3, that would be at 4. And I go up 1, 2. So my new vertex on that line is 4, 2. Okay? Now I would just go ahead and take these points, maybe do a little bit of a T-chart to see how that curve's going. Obviously, I am 1 unit from my asymptote, so my asymptote now will be at 3 because of that H shift. Okay, and this, your H should be equal to your asymptote, so that should make sense too. I've moved over 3 units, but my H is my asymptote. My X cannot equal 3 here. Okay, same thing here. My asymptote will be that X can't equal, now in this one it's -4. And when I move this vertex over 4, I go 1, 2, 3, 4. I'm at -3 for my vertex, but my asymptote is over here at the 4. Okay? Now I do need to go down 2, so don't forget to go down 2 for my vertex. And that's how I'd graph it. Okay? Same thing that you've been seeing since Algebra 1 with the HK shifts. Okay, now we're going to look at the A values. My parent function I've already graphed here, the log 1/2 x. There it's going. Okay. Now I'm going to stretch it by 2. So with a stretch by 2, I still cross at 1, 0. But here in the original, where it was 2, 1, 2, -1, now I'm going to actually do a multiplication of that distance. Instead of it being -1, it should drop down to 2 times -1 would be -2. So you're going to see a little bit of a stretch here. That really should come in more. But it's going to go right through the 1 and then it's going to come out more. Like that. So the stretch is off the x-axis still. Okay? Okay, now on the -1/2, negative is going to flip it across this x-axis. Okay, and actually I said the stretch is off of the x-axis. We'll have to play with that in class. It might be off that y-axis actually as it comes over. So remind me to check that. Actually, let's look at that real quick right now. So when I plug in 2 for x on this, log 1/2 2, it would be a -1. Okay? And so when I do it here, log 1/2 2 equals, I have the 2 in front, it's -1, it's negative, oh yeah, it's -2. Okay, so we're good. Just what I told you. Okay, mental thoughts. Okay, now on the -1/2, what's going to happen is it's going to flip across the x-axis and it will be shrunk down to the x-axis. So instead of the distance being twice as far there, it's going to be half the distance. as it comes off that way. Okay? First it flipped, and then it's half the distance on all the points that you see in the old function. Okay? So that's that. And then watch the last section of the last film on 7.1 if you want to see how to transform finding the equation from a graph. Okay, we'll catch you in class.